So we're going to get started on the exercise. I'm on page 6-64. And the first thing it says is find the pipe size to meet the standard hydraulic gradient of 1.13 feet to the inlet or edge of pavement elevation. Now, step 1 says add the areas that contribute flow to each pipe segment for each of the pipe segments. The total impervious area C is equal to 9.5. So what it's saying here is in that first, and notice how it's written here, and I'll zoom in, it's total area from P1 or P1 to 2, incremental area, S1 has no upstream pipe, okay? So its area here, the total would be 0.3, okay? Now, I'm actually going to, I believe I'm going to explain it where I have all of the data filled out so you can see the formulas as we go along, okay? And I will print this both in color and black and white and post it to Blackboard so you'll have it also, okay? Now, because 1, we need to go through it so you can understand it, and then 2, so you can do the homework assignment because it'll be similar to this. So what you're going to do on the next one, it says P2 to 3 incremental areas S1 to S2 plus P1 to P2. So notice that the next one on this is 0.5. And the reason it's 0.5 is because I'm adding 0.2 and 0.3. So that incremental area that's going to that inlet is 0.5. So if you look at the sketch, it's saying, okay, the impervious area is 0.3 to that inlet, and it's 0.2 to this inlet. So the total impervious going to that inlet is the 0.2 and the previous reach of 0.3, okay? So that's how you're going to do each one of those. Now, I want to show you, instead of just doing the math of 0.3 plus 0.2, this is a formula. So you're going to hit the equal sign, and I'll escape, and I'll delete that. I'll put it above it just so you can see that I'm doing the formula right. I'm going to say equal sign, and I'll zoom in just a little. Well, apparently you can't zoom while you're already in a command. So I'll go equals 0.2, and then you can hit the plus sign on your keyboard by the keypad, and that one. All I did was hit equals, that cell, and that cell. All right? So that's how I'm getting these values. Now, here's the thing that the reason you have to switch back and forth to the sketch is because some of these are, if you look at it, some of these don't have area draining to it. Like this one doesn't have any area draining to it, okay? It's just going to be 0.3, 0.2. It's going to still be the same 0.5. This one's going to be the 0.5 plus 0.15, okay? So it's helpful to have the sketch to write it out if you're a visual person because you tend to get lost possibly in an Excel sheet. But I keep doing that. And I wrote these to be helpful. When you're reading this, you're going from structure 1 to structure 2, structure 2 to structure 3, structure 3 to structure 4. So notice in structure 3, there's 0 and 0 because it's a manhole. And I tell you it's a manhole. These are P5 inlet types. That's a manhole. So no flow goes to it. So that's why that 5 and that 5, or 0.5, is there. The next one says structure 4 to structure 7. So if I look at structure 4 here, going to structure 7, then in structure 7, I have a certain, I have the amount of 0.4. So if you look at this equation, all it does is take the previous one and that one and add it together. You don't have to keep tacking up. If you know something is coming from somewhere you've already previously calculated, don't reinvent the wheel and add forward. Okay? And you'll see you'll notice over here on this one, it's saying it's going from P3 to 4. So it's 0, 0.5 equals 0.5. Now it's going 4 to 7, 0.4, 0.5 from the previous one to 0.9. That's how it's moving. Now, moving to the next page, we've got P5 to 7. So here's P5 to 7. So it's only got, now you have to take a look, there's no upstream pipes of P5. So if you look at P5 right here, there's nothing going to it but the overland area, okay? So P5 is going to have only the value next to it, okay? P7 to 8, so here's P7 to 8. Now, P7 is a manhole again, so it has no flow. But it'll actually take, if you look at 7, it takes the flow or the area from P4 and the area from P5. So that's why you've got the area from P4 and the area from P5. So if you look at the cells, it's the area from P4 and the area from P5. Now it does not matter which order you add these in. I just clicked on that one first and that one second. All right. Now, the next one is total area to the structure from P6 to P8. So here's 6 to 8. Now, if you look at 6, there's no upstream pipes. So here's 6 right here. There's no pipe going to it. Okay. So its area is just the area that's going to the inlet itself. The next one is going to be area from 8 to out. So it's incremental from what's discharging to 8, that 0.25, and the previous area that was going to 7. And this is this is what I'm saying about performance. So it's, let me switch. It's whatever was coming from 6, whatever's coming from 7, and going out. Okay? Now, so we've got 0.6, or what was going to 8, and we've got from the area from the structure 7 and the structure 6. All right? Now, the next part says the same approach is applied to the drainage areas associated with a pervious runoff coefficient. Now, remember when it says pervious and impervious, pervious is the 0.2 is the lower value. It's going to be something like grass. 0.95 is asphalt. Okay? It's going to be asphalt, concrete, something that does not allow water to seep into it. Okay? So you're going to do the same process over. Okay? You're going to just do the same as you did with the impervious area. Okay? So I'm going to pause here and then we'll go to the next step.